Not so exceptionally distant from Earth, generally speaking, researchers have found a new planet known as Proxima B. Stargazers as of late uncovered the most keen picture ever captured of Proxima B using the notable James Webb Space Telescope. This planet orbits the star closest to our Sun, and this wonderful picture offers a remarkable look into a world outside our nearby planetary group, raising questions and excitement among researchers overall. The image, unveiled recently to gasps from astronomers worldwide, isn't just a picture. It's a window into a place that might, just might, hold the ingredients for life. But how did we capture this cosmic portrait? What does this planet, bathed in the glow of its red dwarf star, tell us about our place in the universe? And could it be a home for oceans, atmospheres, or even living things? This journey across the stars may bring us closer to unraveling the mystery of Proxima B and illuminate what this discovery truly means for humanity's quest to find life beyond Earth. Picture a star small and fiery, glowing with a ruddy hue against the velvet black of space. Proxima Centauri, a red dwarf, is no giant like our Sun. It's a cosmic lightweight, barely a tenth of the Sun's mass. Yet it burns with a fierce energy that will outlast our star by trillions of years. Around the stellar ember, Proxima B twirls in a tight orbit, completing a year in just 11.7 Earth days. Imagine that, a year shorter than a Netflix subscription. The planet is so close to its star, about 20 times closer than Earth is to the Sun, that it's likely tidally locked in a celestial waltz, with one side basking eternally in starlight, while the other shivers in endless night. This tidal locking paints a world of extremes, where the boundary between day and night might be a twilight zone of possibility, a place where conditions could teeter on the edge of habitability. What makes Proxima B so tantalizing is its position in the habitable zone, that elusive Goldilocks region where it's not too hot, not too cold, but just right for liquid water to pool on a planet's surface. Water, as we know from Earth, is the elixir of life, the cradle for everything from microbes to whales. Proxima B receives about the same amount of energy from its star as Earth does from the Sun, sparking questions that keep astronomers awake at night. Could this planet harbor seas that ripple under alien skies? Might it host an atmosphere that shields life from the harshness of space? Or is it a barren rock, scorched by its star's tantrums? These questions aren't just scientific. They're deeply human, tugging at our innate curiosity about whether we're alone in the cosmos. The discovery of Proxima B itself is a triumph of human ingenuity. Back in 2016, astronomers using the radial velocity method, a technique as clever as it sounds, spotted this planet by observing its star wobble. Imagine a cosmic tug-of-war. As Proxima B orbits, its gravity nudges Proxima Centauri ever so slightly, making the star shift back and forth. This movement changes the star's light, stretching and compressing its spectral lines in a pattern known as the Doppler shift. It's like hearing a siren change pitch as an ambulance zooms by. But instead of sound, astronomers track light to reveal a planet's presence. This method, honed over decades, confirmed that Proxima B exists and orbits in the habitable zone of the closest star to our Sun. That revelation sent ripples through the scientific community, igniting dreams of studying a world so close and yet so unreachable. Then came the James Webb Space Telescope, humanity's most ambitious eye on the universe. Launched in December 2021 after years of anticipation, this golden marvel floats 1,000,000 miles from Earth, perched at a cosmic vantage point called the L2 Lagrange point. Its 6.5-meter mirror, a mosaic of hexagonal panels, drinks in faint light from the farthest reaches of space. Unlike its predecessor, the Hubble Space Telescope, Webb is tuned to infrared light, the invisible glow that Proxima B emits as it reflects and absorbs its star's energy. This infrared vision is key, because red dwarfs like Proxima Centauri shine brightest in this wavelength, and so do their planets. When Webb turned its gaze to Proxima B, it didn't just see a blur. It captured a portrait so detailed, it revealed hints of the planet's surface, perhaps even traces of an atmosphere. How did Webb pull off this feat? It's a story of precision and patience. The telescope's instruments, cooled to near absolute zero to avoid interference from its own heat, can detect the faintest whispers of light. For Proxima B, Webb likely used a technique called direct imaging, where it blocked the star's glare to focus on the planet's dim glow. This is no easy task. Imagine trying to spot a firefly next to a spotlight. Webb's coronagraph, a device that masks starlight, made this possible, while its infrared cameras teased out details invisible to other telescopes. The result is not just a scientific milestone, but a cultural one, a testament to what humans can achieve when we dare to look beyond our world. Yet even with this breathtaking image, Proxima B remains a puzzle wrapped in a mystery. Its position in the habitable zone is promising, but red dwarfs are notoriously temperamental. Proxima Centauri is a flare star, prone to sudden bursts of energy that bathe its planets in ultraviolet and X-ray radiation. On Earth, our magnetic field and atmosphere shield us from the sun's outbursts. But Proxima B might not be so lucky. Its star's flares could strip away any atmosphere, leaving the planet as bare as the moon. Even if an atmosphere clings to Proxima B, it might be a choking shroud like Venus, with its runaway greenhouse effect, rather than the breathable air we dream of. Scientists like Ed Turner at Princeton have warned that habitability is more than just being in the right place. It's about having the right conditions, from a protective atmosphere to a stable climate. Water, the holy grail of astrobiology, is another open question. On Earth, water covers 70% of the surface, shaping life as we know it. For Proxima B, water could exist in many forms: vast oceans lapping at rocky shores, ice locked in the planet's dark side, or even hidden reservoirs beneath the surface like those on Jupiter's moon Europa. Webb's infrared data might hint at water's presence by detecting its spectral signature, a unique pattern in the light reflected from the planet, but confirming liquid water is a tall order, requiring not just advanced tech but also a bit of cosmic luck. Some models suggest Proxima B could have a temperate region where water pools, especially in that twilight zone between eternal day and night. Others paint a grimmer picture, with water boiled away by stellar flares or frozen in inaccessible depths. Beyond water and atmospheres, Proxima B's very nature fascinates us. Is it a rocky world like Earth with mountains and valleys, or gas-shrouded giant more akin to Neptune? Current data leans toward a rocky planet roughly 1.2 times Earth's mass, but we're still piecing together the clues. Its tidal locking adds another layer of intrigue. The day side might be a scorched desert, the night side a frozen wasteland, but the strip between them could be a haven, a place where temperatures allow life to take root. This idea of a habitable band fuels speculation, from microbial ecosystems to complex organisms adapted to a world of stark contrasts. Proxima B isn't alone in its cosmic neighborhood. It shares its star system with Proxima Centauri C, a larger planet farther out, and orbits within the Alpha Centauri system, a trio of stars that includes the brighter Alpha Centauri A and B. At 4.2 light-years, Proxima Centauri is our closest stellar neighbor, a red dwarf discovered in 1915 by Scottish astronomer Robert Innes. Its faint glow, with an apparent magnitude of 11.13, hides it from the naked eye, but its proximity makes it a beacon for exploration. The Alpha Centauri system, with its 3 stars dancing in a gravitational ballet, reminds us that our cosmic backyard is alive with possibilities, each star potentially hosting worlds we've yet to discover. The discovery of Proxima B and its imaging by Webb mark a turning point in our search for exoplanets. With an estimated 206 trillion stars in the universe, the number of planets could be staggering. Some wander alone, rogue planets untethered to any star, while others, like Proxima B, orbit in systems as diverse as the galaxies themselves. Each exoplanet is a piece of the puzzle, helping us understand how planets form, how stars shape their worlds, and whether life is a cosmic fluke or a universal constant. Proxima B stands out not just for its proximity, but for what it represents, a chance to study a potentially habitable world up close, relatively speaking. What does this mean for the future? Proxima B is a siren call for exploration, but reaching it is a daunting challenge. A spacecraft like Voyager 2, plodding along at 34,000 miles per hour, would take 23,000 years to arrive. Yet the dream persists. Concepts like Breakthrough Starshot, which envisions tiny laser-propelled probes, hint at a future where we could send emissaries to Proxima B within decades. For now, telescopes like Webb are our best tools, peeling back the layers of this distant world one photon at a time. Each observation brings us closer to answering the ultimate question: does life exist beyond Earth? As we gaze at Proxima B's image, we're not just seeing a planet, we're seeing ourselves reflected in the cosmos. This world, so close yet so alien, challenges us to rethink what's possible. It's a reminder that the universe is vast, but not beyond our reach. Whether Proxima B is a lifeless rock or a cradle for life, it's a stepping stone, a spark that ignites our curiosity and drives us to explore. So let's keep looking, keep dreaming, and keep chasing the light of distant worlds. The next discovery might just change everything. Still, as breathtaking as the image of Proxima B may be, and as tantalizing as the data we've collected is, the real value lies in what it inspires: the sense that the universe is not static, but ever-evolving, rich with surprises that await discovery. Each new observation is a stepping stone toward answering questions older than civilization itself. Are we alone? Is Earth unique? Or is life a cosmic inevitability? These aren't just idle musings. They are the driving force behind some of the most complex, expensive, and ambitious undertakings humanity has ever pursued. What makes Proxima B such a compelling target isn't just its proximity, but the way it forces us to push the boundaries of what our technology, our theories, and even our imaginations can do. Just a few decades ago, exoplanets were a theoretical possibility. Today, we've cataloged thousands. The rapid pace of discovery has only fueled further speculation, and Proxima B, sitting so close in astronomical terms, becomes the focal point of those hopes. And it's not just scientists or space agencies who are captivated. Proxima B has entered the popular imagination. It shows up in science fiction novels, in speculative documentaries, and in the minds of children who gaze at the night sky wondering what lies beyond. This cultural penetration matters. It fuels funding. It inspires future scientists. And it binds humanity together under a shared curiosity. When the James Webb Space Telescope beamed back its data, streaming light that had traveled for years across the void, it wasn't just astronomers who paid attention. For a fleeting moment, the entire world turned its collective eye skyward to that tiny pinprick of light orbiting a distant fiery ember. And there, in that brief glimmer, was hope. Hope that we're not adrift and alone in an empty cosmos, but part of something far grander. Future missions to Proxima B are already being discussed with growing seriousness. Breakthrough Starshot, a private initiative backed by some of the world's leading minds and tech moguls, proposes launching microprobes, each no bigger than a postage stamp, at a fifth of the speed of light using powerful lasers. These probes, if successful, could reach Proxima B in just over 20 years, transmitting data back that would revolutionize our understanding of the planet. No mission has ever attempted anything so ambitious, but the idea is no longer science fiction. It's being engineered and debated in real time. Alongside these dreams, new generations of telescopes are also being designed. The Extremely Large Telescope, ELT, the 30-meter telescope, TMT, and others will add clarity and depth to what JWST has begun. As these Earth-based behemoths come online in the next decade, they will enhance our view of Proxima B with even more detail, perhaps capturing dynamic weather patterns, geological changes, or even signs of seasonal variation on its surface. But no matter how advanced our technology becomes, Proxima B reminds us of a fundamental truth: the universe doesn't yield its secrets easily. It demands patience, resilience, and a willingness to embrace ambiguity. For every discovery, there are dozens of new questions. For every confirmed data point, there are uncertainties, assumptions, and margins of error. Scientists are constantly revising their models, reinterpreting their observations, and refining their instruments in pursuit of a clearer picture. That's the nature of exploration, not the pursuit of certainty, but the acceptance of complexity. Proxima B may not be Earth 2.0. It may not even,